Okay, this section of the video is for system of equations, which is the apparent solution set of the system of equations shown in the graph. Okay, so if it's a system of equations, the solutions are going to be the intersections of the two graphs. Okay, so I see two intersections. I have a circle and then I have a line going through that circle. So my apparent solutions are at 3 and about negative half. And then we have negative 2 and about 2. So that will be this answer right here. And there are approximations. All right, let's look at the next one. Consider the graph. How many solutions exist? So how many solutions on a system of equation is all the intersections of the two graphs? 1, 2, 3, 4. There are 4. Circle the solutions. I just did that. Approximate all of the solutions. So I'm going to give you an example of each of these. So I have here, okay, this one is about so the apparent solutions for this guy right here, that's about 2.5 and 0.5. This intersection right here is about 1.75 and negative 3.5. This solution right here is about at 0, negative 4. And then this solution up here is about negative 1 and 1.75. So those are all of the solutions. All right, let's go on to the next one. Okay, so all of these we need to solve. So when we're solving the system of equations, we want to know the intersection. So the first two have a graph, so you need to be able to graph, and the other ones don't have a graph, you just need to list the solutions. Remember that these always have to be in standard form, which means I'm going to have y equals. You can also do this algebraically. I am just going to show you graphically and through the calculator how to do it though. If you want to do it algebraically through substitution or elimination, check with your Algebra 2 teacher. Okay, so let's look at the first one. Notice here I have y equals, okay, I have y equals x plus 2. All right, and then I have x equals negative 3. Well, I know that x equals negative 3 is a horizontal line, so I'm going to go ahead and draw that. X equals negative 3. All right, and then I have my other one. All right, and remember to go to the table to plot some points if it asks you to graph it. So I'm going to start at negative 4, negative 2. All right, so I just took some values out of my table and graphed both lines. Remember, again, the intersection is the solution. So in this intersection, there's just one intersection, and that intersection is at negative 3, comma, negative 1. So when you have a solution, you're going to have an x and a y value. Okay, let's do the next one. Go ahead and put it into the graphing calculator. Notice for this one, we have a quadratic and a linear function. So we're going to go ahead and put those into y equals, and we can see that the line goes through that parabola. So the first thing you want to do is graph it for this particular problem. So you go ahead and go to the table. The y1 is going to be the y values for your quadratic, and then the y2 is going to be the y values for your linear function. So go ahead and take a second and graph those. All right, I went ahead and sketched that in, and I see that there's two intersections. There's one here, okay, and that intersection is going to be 0, 1. And then I also have this intersection right here, which is at 1, 2. Now, if you look at the calculator, you kind of can't tell that there's two intersections, but if you zoom in, you can see there are two distinct intersections for this particular problem. Okay, so if you're not sure, zoom in, make sure you're getting both intersections. Now the other two I'm going to show you how to do into the calculator. First thing, again, it has to be in standard form. Notice that the first two we did were already in standard form. So if it is not in standard form like this one, you want to get y by itself. So for the first problem, I'm going to plus y on both sides. So that's x squared equals 5 plus y. But again, I want y by itself, so I'm going to subtract 5. So I have x squared minus 5 equals y. And then here, again, I need y by itself, so I'm going to plus 3x plus 3x. So y equals 3x minus 7. So I have this one, and I have this one. You can go ahead and put that into the calculator. Okay, and zoom 6 will take you to your normal viewing window. Okay, so for this particular one, it looks like maybe I have two, maybe I have one intersection, so you can zoom in to see. Okay, now I can't really tell, so I'm going to zoom 6 again. And if you move your cursor to exactly where you want it to zoom in, then you can zoom in to that particular point. That's better. Okay, so there are two distinct points. It's very, very slight, but there are two distinct points. So the calculator, you can do intersection. To find those two intersections, you have to do it twice. So again, second trace. We did this in the earlier video. Second trace. And you're going to do intersection, which is number 5, for however many intersections you have. So intersection 5. So I'm going to go close to that intersection. Press enter 3 times. So there's one of the intersections. So I have 1, comma, negative 4. And then second trace again. Back to intersection. This time I'm going to move up to this other intersection. Enter 3 times. And that's 2, comma, negative 1. Alright, looking at the next one. Again, this needs to be in standard form. I see my first one is in standard form, the second one is not. So plus 10x. Plus 10x. So I have y equals 10x minus 1. Go back, put that into y equals. I've got both of my equations in, and then I'm going to do a zoom 6 for a normal viewing window. Notice that this parabola is very wide, and I see an intersection here, but I can't see the other intersection. So let's zoom out this time. Okay. So I see there's an intersection down here, and I have an intersection up here. So we're going to second trace, intersection. I'm going to move up here because I have one intersection that's about right there. Enter 3 times. So that's 0.33 repeating, comma, 2.3 repeating. And then I'm going to do my other intersection. This time I'm going to move down. And press enter 3 times. Notice it gave me the same intersection. So let's try that again. Okay, and that time it gave me the right intersection, which is negative 4, comma, negative 41. So remember that you've got to get the cursor close to the intersection for it to give you the correct intersection. Alright, again, next, make sure that it's in y equals. It is not. The first one is, so minus x squared on both sides. So y equals negative x squared plus 17. Put those both into y equals. And I put it into y equals. Zoom 6 of a line and a parabola. Notice there's two intersections. There's one very visible here, and then there's one off of the screen. So this one you want to zoom out. Okay, and now I can see both. So we're going to go into the calc table. I'm going to do intersect. Remember, you want to move close to the intersection and then press enter 3 times. So the intersection is at 3.6, comma 4.2. And then you're going to do that a second time. And this time move over to the other intersection, enter 3 times. And that's negative 5.6, comma negative 14.2. Okay, last one. This is a parabola and a parabola. So go back to y equals. All right, so we have our two quadratics and our y equals. They were already in standard form. Zoom 6. You notice the placement of these two parabolas. You have two intersections here, which it can be more than two, but this particular one has two. So second, trace, intersect. Remember, go towards that intersection, enter 3 times. So I have negative 7.77, comma 6.9, and then we're going to do that again. Intersection, move down. This is off the screen, but just off the screen, so it probably will find the intersection for you, which is at 3, comma 2. Let's say 3.3, comma negative 11.2. Okay. Number 15 says, draw the graph of a system that meets the following requirements. 2 functions, 1 quadratic, and 1 linear with exactly 1 solution. Okay, so a good example of that would be a parabola that, say, has a vertex. Okay, and our vertex right here is at negative 2, 1. So negative 2, 1. But then I have a horizontal line, which is y equals 1. So it's only going to connect in that place right there. So I have a quadratic and a linear function. There's only one solution because the parabola is going up. So there's only one solution, and that solution would be negative 2, comma 1. That would be one solution. Okay, the next one says, draw a graph of the system meets these requirements. 2 functions, 1 quadratic, 1 linear, has 2 solutions, one at negative 1, negative 2, so negative 1, negative 2, and then the other, which is at 3, 2. Okay, so the first thing, we know we need a linear one, so that one's kind of the easy one. So make this a linear one. So the line has to go through those 2 points. And then the next one, the parabola, it could be several different ways because I only have 2 points, so I get to pick my 3rd point. So let's say that my parabola looks like this. So then I have 2 solutions, which are here and here, and I have a line and I have a quadratic. All right, the next one says, draw a graph of the system that meets these 2 requirements. 2 quadratics with 2 solutions, one at negative 2, 1, and one at 2, 1. Okay, so maybe I have a parabola that faces this way. And then I also have a parabola that faces this way. Will give me my 2 solutions. Okay, a couple other that aren't in here that I want to make sure that you know. One is if there's no solutions. So no solutions, which isn't on your paper, but you should be aware of it. No solutions would be, say, a parabola that faces up, but then you have a parabola with a vertex that faces down. So this would be no solutions. Because it has to have an intersection to have a solution for a system, so this would be no solution. For lines, parallel lines, they are never going to intersect. That also has no solutions. Okay. And then there's lots of different other things. We looked at some on the other page, whether it's a circle and a parabola. So remember, whether it's asking you to answer the question, how many are there? So this one has 2, this one has 1, or is it asking you what is the solution? If this asking what is the solution, it's asking for where the intersection is.